Hi everyone. So in chapter 8, we're going to learn about all different kinds of transformations. So today we're starting with translations and reflections, which I think we've had some experience before with these. So a translation is also known as a slide, and a reflection is a flip, which is what you might have called them back when you learned them previously. So we're going to start off with translations. And we're going to do it a couple different ways. We're going to use a graph, and then we're going to use just the points and the rules that we're going to write. So for our first example, it says that we have triangle XYZ, and we're going to graph the image of the triangle after it translates 5 units to the right and 2 units down. So the shape or the figure that we start with is called the pre-image. And then the one that we get after we do the transformation is called the image, which is why they called it image up there. When we look at the ordered pairs, if you look at the letters that are with your pre-image, they just have an X, a Y, and a Z. So that shows you that it's your original figure before you do anything to it. When we talk about the points after the transformation, we use the little marks above it. They're called prime marks. So this would be X prime, Y prime, and Z prime. So after we do our transformation, we're going to find the ordered pairs. So we're going to move each point 5 units to the right and 2 down, which will move our whole triangle. So from Y, we're going to move 5 to the right and 2 down. So that'll be our new Y point, or we're going to call it Y prime. So we're going to count all of the other points as well, 5 to the right and 2 down. So here's Z prime, and then we'll do the same thing for X. And there's X prime. So once we finish moving our point, you'll just connect them to make your triangle. You got to make sure you label your points with the prime marks and their letters. So now we'll just look for all the values at each point. So X prime is 0, 3. Y prime is 1, 6. And Z prime is 6, 1. Okay, very good. Why don't you pause and try example number 2? We're doing the same thing, except this time we have 4 points, but the process is still the same. You'll count each point, how much you have to move it. So pause and complete example 2, please. Okay, so this is what your image should have looked like after you completed the translation of moving it 3 units to the left and 4 units up. Very good. Okay, so let's try to do transformations or translations with just the variables. So they also write the rules like this, what we're going to do here. So we have triangle XYZ, and then they gave us the ordered pairs, which I listed down here. So those are the vertices of triangle XYZ. We want to find the vertices of X prime, Z, Y prime, and Z prime after we translate it 7 units to the left and 3 units down. So if I move 7 units to the left, what am I going to be doing to my X values? Am I going to be adding those 7 units or subtracting? Good, we'll be subtracting 7. If we move to the right, that's when we're adding. And if we're moving 3 down, is that adding or subtracting? Good, we'd be subtracting. So we'll subtract 3 from our Y's. So this will be like our work column to show what we've done. So our original X value minus 7, our original Y value minus 3 will give us the new X point of -4, -2. So obviously this column is just so we can show what we're doing, but we really just did 3 minus 7 and 1 minus 3, and that's how we got those values. So let's try it with Y. So our original X value minus 7, and then our original Y value minus 3. So our new Y prime point will be at -2, 3. So for Z, we got 5 minus 7, -1 minus 3. So our new Z prime point will be at -2, -4. Okay, so let's try example 4. We need to do the same thing. figure out what your rule is, what we're doing to x and y. Remember, if you move left, you're subtracting. If you move right, you would be adding. And if you move down, you're subtracting. Up would be adding. There was one typo on here. It said x, y, and z, but our points are a, b, and c. So we're finding the vertices of a prime, b prime, c prime, d prime. So go ahead and pause and try to work out that example. And then when you come back, I will show you the answer. Okay, so our rule was to go right 3, so we're adding 3, and up 6, so it'd be plus 6. So here is our a prime, b prime, c prime, and d prime points. So make sure you write down any questions you have, and we'll go over them in class tomorrow. So the second half of our lesson today is on reflections, which is the other pink notes that you have. Okay, so reflections, there's rules for those too. So we're going to do a couple different kinds. So we're going to reflect over the horizontal line, which is the x-axis, or we're going to reflect vertically, which is the y-axis, or we can reflect over these other lines, x equals y, or x equals negative, or sorry, y equals x, or y equals negative x. Okay, so we have our rules here. So reflections across the x-axis, this is what happens to our points. So it would go from xy to x negative y, so the y becomes the opposite. If we reflect across the y-axis, x becomes the opposite. And then for reflecting across the line y equals x, our x and y switch. And for y equals negative x, they switch and become opposite signs. Okay, so let's take a look at our first example. So we're going to reflect across the x-axis. So remember, x is the horizontal line. So this is the line that we're going to reflect over. So on the front, it says that if we reflect over the x-axis, we just have to, for any reflection really, you're just counting how far away those points are from that line. You could use that rule, that x negative y rule, but it's just easier to count. So if a is 3 above, then a prime will be 3 below. So this is a prime. So b is 5 above, so b prime will be 5 below. And c is 2 below, so c prime will be 2 above. And notice I'm staying like on the same x value. Remember, that doesn't change because our rule was that x changes, y becomes the opposite. So after that, we'll just connect our lines, our points, and that is all. Okay, so let's try the one below that. So this time we're reflecting across the line y equals negative 2. So it's not the x-axis anymore. It's a line y equals negative 2. So you have to think back from algebra how to graph that. We know it's going to be a horizontal line because we're in the horizontal graphing column. But y is at negative 2 right here. So that means that it's along that y equals negative 2 line. Okay. So y equals negative 2, or y equals any just number with no x, it's always going to be a horizontal line. So now we're going to do the same thing that we did for the first example, but that green line that I drew is the line that we're counting away from. So a is 4 points above, so a prime will be 4 points below. B is 2, 4, 6 above, so b prime will be 2, 4, 6 below. It doesn't really fit, so I just drew some lines on there. C is 1 above, so c prime will be 1 below. And d prime is on the line, so it doesn't change at all. That's where it's going to stay. D prime. And that is how to reflect over a line that's not an axis. Okay, so let's go up here. This time we're reflecting across the y-axis. So that is this line right here, the vertical one. So we're flipping it from this side over to that side. So same idea. We're going to count how many points we are away, but this time it's going to be a horizontal change. So we're 1 and 1. This one's 6, so we'd be 6. 3, 3. Forgot my prime marker there. And that is it. That's how we reflect off those points, or those lines. Okay, so I want to show you one more thing before I let you practice this on your own. So for this one, remember if we had y equals -2, it was a horizontal line down there at -2. So this one says x equals -1. So that means we're going to have a vertical line, and that's the line that we flip over. Okay, so I want you to pause, and I want you to complete this example and then those bottom two, and when you come back, I will show you what they should look like. Okay, so here's a reflection of y equals -x. Down here we got y equals 3, and over here x equals 2. So as you can see, sometimes they flip over and like end up being like on top of each other, and sometimes they don't. So it doesn't really, and then sometimes like this one, they don't even touch. It depends on where the points are and how far away from the lines they are. Okay, so our last kind of reflection is flipping over that y equals x line. So let's take a look at that first example. Okay, so y equals x is a horizontal line that has an intercept of 0 and a slope of 1. So we would have like 0 and then rise 1, run 1. And then we could keep going and making that line. So it's a slanted line. It goes through those points that I just made. Maybe I can make it straight. Not really. Okay, so that's the line that we're flipping over. So remember from the front, the rule said for flipping over y equals x, the way we find our other points is we switch our points. So we're going to have to look for what our points are for our original one, and then we're going to flip it. Okay, so our point A is at -4, 2. Right down here. So A is at -4, 2. So that means that A prime is going to be when we would switch it. So our A prime is going to be at 2, -4. So 2, -4. So that is A prime. So B is at 5, -1. So B prime would be at -1, 5. -1, 5. B prime. So our C point is at 2, -3. So switch them when you have -3, 2. -3, 2. So then we'll connect, and that is it. So that's what we get. They're kind of really on top of each other for this one. When you get to algebra, this is called they're inverses of each other because they flip over that y equals x line. Okay, so I'd like you to pause and try this example, and then we'll try that last one together. So do the second example in the reflection of y equals x line. Okay, so this is what we should have had. It was another one where they ended up on top of each other. Remember, if the point lands on the line of reflection, then it doesn't move. It stays right where it is. So that C point ended up on the same spot. Okay, so let's talk about the last one. So reflecting over the line y equals x. So our line of reflection is not going to be the same as it was for those first two examples. We still have a y-intercept of 0, but our slope's negative this time. So we would do rise or run. So we're going negative direction now. So this is the line that we're flipping over. Okay, so the rule in the front said that if we're reflecting over y equals -x, we switch them and make them the opposite sign. So let's find our points. So first we have A, and A is at -4, +6. So that means our next one, we switch them and change the sign. So this will become negative and the 6 will become, or I'm sorry, that'll become positive and the 6 will become negative. So B is at 2, 2. So I switch them and make them the opposite signs. So they both become negative this time. C is at negative 6, 3. So switch them. And then opposite the signs. So 3 was positive, so it's negative. 6 was negative, so now it's positive. So then we would just graph those points, and that's the reflection over y equals negative x. So after you do that, it should look like this. Okay, so make sure you write down any questions you have, and we'll talk about them in class tomorrow.